All right, welcome to the Explainer. So, have you ever opened the Chrome DevTools Performance tab, looked at it, and just felt completely lost? Yeah, you're not alone. Today, we're going to demystify this thing once and for all. Okay, so here's what we're going to do. We'll kick things off by figuring out what slow actually means. Turning those fuzzy user complaints into cold, hard data. Then, we'll walk through how to record a performance profile. I'll show you how to read that crazy-looking flame chart, and we'll pinpoint the exact culprit slowing your site down. Right, so where does this journey usually begin? Well, for a lot of us, it starts with a user support ticket, something that probably looks a little too familiar. Flickers, jerky. What are you supposed to do with that? It's pretty vague, right? But what this user is really describing is a classic case of bad runtime performance. This isn't about how fast the page loads. It's about what happens after it's loaded, when someone actually tries to use it. And believe it or not, that jerkiness has a name. It's called jank. Yep, jank. It's that awful stuttering feeling you get when the browser just can't keep up with that smooth 60 frames per second goal. You see, slow isn't just one single problem. It's usually a nasty mix of these three things. You've got JavaScript tasks that run for too long, blocking everything up. That causes dropped frames. And then you have content just jumping around the page, which we call layout shifts. Our mission, should we choose to accept it, is to play detective and find the main culprit. So, to get to the bottom of this, we have to stop guessing. We need to go from "it feels jerky" to "here is the data." And that means it's time to fire up DevTools and record a profile. Now, the process itself is pretty simple. You just open the performance panel, hit that record button, and do the thing that's causing the problem. But, and this is super important, don't forget to simulate a slower CPU. Your dev machine is probably a beast, right? Throttling it down gives you a way more accurate idea of what an average user on a less powerful device is actually seeing. And boom, there it is, the flame chart. I know, it looks like a total mess, just a big wall of color. But trust me, once you know the rules of the game, it's actually not that bad. Let's decode this thing. Okay, it's really simpler than you think. You only need to remember two things. Left to right, that's time. So a wider bar means something took longer. Easy. Top to bottom, that's cause and effect. The thing on top caused the thing underneath it. See? Time and causality. That's the whole key. Now, the colors are basically your cheat sheet. They tell you what the browser was busy doing. See a whole bunch of yellow? That's your JavaScript. And long, wide yellow bars? Oh yeah, that's your prime suspect for a frozen UI, right there. The purple and green stuff? That's all about rendering and painting. The work the browser has to do after your script is done. And here's a little pro tip for you. Navigate this thing like you're playing a video game. Seriously. Use the W and S keys to zoom in and out, and A and D to pan left and right. It is so much faster than trying to click and drag with your mouse. Okay, so now that we know how to read the map, let's go on a little treasure hunt. Or, well, maybe a bug hunt. We're looking for the biggest, most common performance killer out there. And our number one suspect is what's called a long task. Think of it like this. It's any bit of code that just hogs the browser's main thread, completely taking it over. When that happens, the browser can't do anything else, like, respond when a user tries to click something. So what's the magic number? It's 50 milliseconds. That's the cutoff. Anything that takes longer than 50 ms is officially a long task. And why 50? Because that's right around the point where a human being can actually start to perceive the delay. That's where the lag becomes real. And this is the smoking gun. DevTools makes it super obvious. It puts this little red triangle right on the task. Whenever you see one of those, bingo. You found a moment in time where your user interface was totally, completely frozen. That's your starting point. All right, let's go back to our user's original complaint. Remember the flickering? Turns out we can actually measure that too. So that flickering sensation is almost always caused by something called a layout shift. And there's even a metric for it, cumulative layout shift, or CLS, which basically gives your page a report card on how visually stable it is. And the best part is, the performance panel makes these super easy to find. There's a whole dedicated track just for layout shift. You can see every single shift marked out, you can hover over it to see exactly what element jumped around, and then you can click on it to get all the juicy details. It's like having a perfect forensic record of everything that moved when it wasn't supposed to. So we've gathered our clues, we've identified our suspects. Now it's time to put it all together and close the case. You know, at the end of the day, all of this stuff ties directly back to Google's core web vitals. Those annoying layout shifts we found, they absolutely tank your CLS score. And those long tasks, they wreck your NINP or interaction to next paint. These are the big metrics that measure how a real user experiences your site. And now we know exactly why our page is failing. So think about it. We can now go back to that original support ticket, not with guesses, but with answers. We can say, hey, that jerky feeling you mentioned, it's being caused by these specific JavaScript tasks that are running too long, and that's causing content to shift around when you scroll. We've even found the exact functions that are responsible. And that is the real power of the Performance tab. You go from a vague feeling, it's jerky, to a concrete, data-backed action plan. You're not just guessing anymore, you're actually engineering a solution. So the only real question left is, what are you going to fix first?